All right, let's start on page 333. Page 333. Yesterday we talked about perpendicular bisectors and angle bisectors of sides and angles in a triangle. And today we're going to talk about medians and altitudes of triangles. So we have two learning targets. We're going to define and identify a median of a triangle, and we're going to define and identify an altitude of a triangle. A median of a triangle is a segment with endpoints being a vertex of a triangle and the midpoint of the opposite side. So I like to think of a median as being a segment that connects a vertex to a midpoint. Okay? Connects a vertex to a midpoint. Now, every triangle will have three medians. Well, how come? Because there's three vertices and then three opposite sides, and those three opposite sides will each have a midpoint, so you get three medians. The medians are concurrent. In other words, they all intersect at one point, and that point of concurrency is called the centroid. So you just need to have heard that word before, centroid, okay? What you really need to know is that a median of a triangle is a segment that connects a vertex to the midpoint of the opposite side. An altitude of a triangle. Now, an altitude sometimes gets confused with the perpendicular bisector because altitudes are perpendicular to the other side, just like perpendicular bisectors were perpendicular to the side. But perpendicular bisectors don't always go through a vertex, do they? For an isosceles or equilateral, we can make them go through a vertex, but just in general, perpendicular bisectors didn't necessarily go through a vertex. Well, an altitude does. An altitude of a triangle is a segment from a vertex to the line containing the opposite side and perpendicular to the line containing that side. Now that seems a little more complicated than is necessary, but it actually is necessary to word it that way. An altitude, informally, we can think of an altitude as going from a vertex perpendicular to the opposite side. But that's not quite right, okay? Because sometimes you'll need to extend that side. Remember when we were finding the distance from a point to a line in a figure, and sometimes we'd have to extend a side so that it could actually be perpendicular? Same thing's going on here. If we look at this figure, that red segment is an altitude because it starts at a vertex, or at least one end is at a vertex. The other end is on the opposite side, and it's perpendicular to that opposite side. But look, if I try the same thing for this triangle, there is absolutely no way to have a segment with one end point at B that's perpendicular to segment AC inside of that triangle, is there? It won't be perpendicular, okay? Any line here I would make is not perpendicular to segment AC. So you extend segment AC, and now you can draw a segment that's perpendicular to it. So that's the reason that the definition of altitude is a little complicated, because it has to take into account the possibility that you might be perpendicular to the line containing that side instead of the actual segment itself. Have I over-explained that? Does that make sense? Okay. All right. And then, like the other things we've had, since triangles have three angles and three sides, there's going to be three altitudes. Okay? And the altitudes may have to be extended, but they will. In other words, it may be have to, not only do we have to extend this side to get this altitude, we may actually have to extend the altitude in one way or another. But they also eventually intersect at a point, and I've forgotten what that point's called, orthocenter, I think. Okay? And let's see, I'll look. Yep, orthocenter. Now, we've talked about this before. Height the length of an altitude is known as the height of a triangle. The height of a triangle is used to calculate the triangle's area and do other things. Now, we tend to use height and altitude interchangeably, they're not really synonyms. They're not really the exact same thing. But if I call something the height of the triangle, and, well, for instance, this segment here, segment BD that we drew in, is the altitude. The length of segment BD is the height. But if you call BD the height, I'm fine. If you say, well, the length of BD is 7, okay. If you say the height of BD is 7, okay. If you say the altitude is 7, technically not correct, but okay. We're conveying, in verbally, we're conveying the right idea. In writing, you got to make sure you use the exact right words. But if you say the altitude's 7, we're okay with that. All right? Now, here's what we've talked about. So far in the last 2 days. So we've talked about perpendicular bisectors, angle bisectors, and today medians and altitudes. Each one is a pretty simple concept. Just keep them straight. Okay? Just don't confuse a median for an angle bisector. Because look, when you draw them in, doesn't that median look about the same as that angle bisector? Right? So just pay attention to the information you're given, or pay attention to what's marked on your figure to know what you're dealing with. All right? How do I know the one that's a median is a median? Well, since that segment's congruent to that segment, that point right there must be the midpoint of that side. Well, a median is the segment that goes from a vertex to a midpoint. Okay? So pay attention to what's given to you, either in words or on the figure. Correct. The angle bisector makes these two angles congruent. The median makes these two segments congruent. That's it exactly. All right, let's do some. We'll start with number 28. That's a weird place to start. But that's where we're starting. The directions say, use the given information to determine whether segment LM is a perpendicular bisector, median, and or an altitude of triangle JKL. And I'm going to have to reorient things now that, oh, it all shows up on yours. Doesn't show up on mine. All right. Let's look at segment LM. Here it is, right here. Now, if all they give us is the figure, then as far as we know, segment LM isn't any of those things. But they give us this information. The triangle JLM is congruent to triangle KLM. Now, we know that if two triangles are congruent, we get 6 pairs of corresponding parts that are congruent. So let's mark those on here, then we can decide what segment LM is. Okay? So, let's do angles first. Angle J of JLM is congruent to angle K from triangle KLM. Angle JLM, which would be here, is congruent to triangle KLM, which is here, which means the angle M of the triangle on the left is congruent to the angle M of the triangle on the right. Then let's get our segments. JL is congruent to KL, LM congruent to itself. I've got it in red, so I'm not going to mark that again. And then JM congruent to KM. Okay, now, let's decide. Let's just go one at a time here. Is it a perpendicular bisector? It's definitely a bisector of segment JK, isn't it? Because JM is congruent to MK. Do I know for a fact that that and that are each right angles? Yes, why?
Because if the triangles are congruent, well, the bottom JK has to be long.
Mm-hmm.
And so a line that comes
Uh-huh.
And the only way to price that to
Exactly. Did y'all follow that? Since this is 180 degrees, and the 180 gets, then there's two adjacent angles. So in other words, those two angles are a linear pair, right? So they add up to 180, and if they're congruent to each other and they add up to 180, they do each have to be 90. So it's a bisector of segment JK, it's perpendicular to segment JK, so it is a perpendicular bisector. Now, is it a median? If it's a median, one endpoint is a vertex, the other endpoint is a midpoint. L is definitely a vertex. Is M a midpoint? Yes. So it's a median. What about an altitude? Does it start at a vertex and perpendicular to the opposite side? Yes. So it's all of these. So it is a perpendicular bisector. It is a median, and it is an altitude. Altitude. Now, they didn't ask us if it's an angle bisector. Is it? It's also an angle bisector. So of the four special things we've talked about, that one segment is each one of those. Now, you know why that one segment is each one of those? Because it goes from the vertex of an isosceles triangle. Okay? That's why that happens. So, sometimes a segment's just one of these things. Sometimes it's more than one. You with me? Oh, really? Was that it? Huh. All right, page 338. Do 16 through 19, 27 through 30, 34, 35, 44 through 47, and back up to the previous section and do 55 through 58.